Okay, so today we are continuing on with trig. We're moving on to lesson 3 in the workbook. Lesson 3 is on page 219. Essentially what this lesson is, it's going to take the skills that I taught you yesterday and we're going to apply it and actually solve triangles. When I say solve a triangle, there's essentially 6 things that you could possibly solve. There's 3 sides to a triangle and there's 3 angles. However, one of the angles must always be what? 90 degrees. So really there's only 5 things that you're solving. What I want you to write at the top of page 219 is write the acronym that I taught you yesterday. So what was that, Cade, what was that acronym? SOHCAHTOA. Yep. All of these questions you'll see, with the exception of the first question, which is going to be Pythagoras' theorem, we are going to use SOHCAHTOA. Okay, underneath each acronym, I want you to write what that ratio is. So I'll do sine and then you guys will do the rest. So S stands for the sine ratio, and it's always going to be the sine of a given angle is equal to, the ratio is 2 sides on the triangle, and sine just happens to be O over H, which is opposite over hypotenuse. You guys? Okay, so that's the sine ratio. Then we go over here. C stands for the cosine ratio. So the cosine of a given angle is equal to A over H. And the last ratio is tan. And the tan of a given angle is equal to O over A. So what we're going to be doing today is we're going to be calculating both angles and ratios based on certain triangles. Before we actually get into trig though, let's do a review from grade 9, which is Pythagoras' theorem. So remember that in a triangle, 3 sides, the longest side of the triangle is called the hypotenuse, and we label that C, right? So A, B, and C. The longest side is C. And Pythagoras' theorem would be C squared equals A squared plus B squared. Okay, so we need to know this formula. Let's apply that formula to this first question here. Calculate the length of the third side of the triangle to the nearest tenth if necessary. So essentially what we're going to do in this question is we're going to use Pythagoras' theorem, and then I'm going to show you after how we're going to use trig to solve this side. So I could have given you this question in grade 9, and you would have said, okay, this just happens to be, I'm going to cross out the x, and I'm going to put C, because that's the hypotenuse, that's the longest side. So C squared equals A squared plus B squared. C squared equals 3.7 squared plus 2.5 squared. So clear your calculators. 3.7 squared plus 2.5 squared. So get that typed in. 19.94. And then at the end, we need to get C by itself. So to isolate C, you would square root both sides of your triangle. And you would get the square root of my answer to the nearest tenth would be 4.5. What are my units? They should say in the question, centimeters, 4.5 centimeters. So C is equal to 4.5 centimeters. Okay. Oh, actually, you guys, one thing I should say. Technically, what's more correct is at the end of the day, I shouldn't call that side C. What do they want me to call that side? X. So I use C because that's what I know that they want me to use in the formula for Pythagoras' theorem, but they actually said, no, please call that side X. So I'd erase the C and I put the X at the end. Okay, sometimes I could draw triangles that look strange like this. But always to figure out C, you give your 90-degree a set of eyeballs, and it stares always at the hypotenuse. So in this case, 122 would be the hypotenuse, and it doesn't matter which side you call A and which side you call B. The formula was C squared equals A squared plus B squared. And then what I want to do is I said, okay, I'm going to solve for B. So I need to get B squared by itself. How do I get rid of this A squared? Do I minus it or add it? You subtract it. To get B squared by itself, subtract A squared from both sides. Then what you have is B squared is equal to C squared minus A squared. Essentially what it is, I never do this. I always just say to myself, if I'm solving for a different side other than the hypotenuse, it is always going to be the hypotenuse minus the other side. So it's always the hypotenuse comes first minus the other given side. So this would be B squared is equal to, the hypotenuse is 122 squared minus 120 squared. Type that in. And you should get, Alexa, do you have it? 484 is correct. And then to isolate B, get rid of your square by square rooting. And we would get 22. Hermes, what is the units for this one? Millimeters is correct. Yes. Yep. That's no problem. You just chose different sides to label and you're fine with that. Yep. Oh, this one. Do you guys know what the check would be that you did this correctly? Yeah, what the check would be, we just got that B is 22, right? So let's type in on our calculator 22 squared plus 120 squared. Let's type in A squared plus B squared. So let's type in 22 squared plus 120 squared. So that's A squared and B squared. And then that would equal C squared. And let's square root that guy. 122. And then I look at my triangle. The hypotenuse is 122. We did this correctly. So this is something you learned in junior high, and fair game. You could solve, if you really want to, using Pythagoras' theorem. Once you guys get trig, though, and you understand trig, you will not use Pythagoras' theorem anymore. We will redo this question, and we will solve it using trig. So that's what we're going to do at the end. We'll go back to this and solve it using trig. Okay, flip your page. And the only thing we're going to do here is we are going to set up this triangle, because remember we have to be able to label our triangles. So which angle do I give a set of eyeballs to between these three angles? 52 degrees. That's my given angle. 52 degrees stares at the opposite side. So they want X to be my opposite side. Then I go to my hypotenuse and I say the hypotenuse, or sorry, the 90 degrees stares at the hypotenuse. By default, this would be the adjacent. What we're going to get into now is I'm going to say we need to solve for X, and you need to use trig to do that. So what you're going to do is you're going to write your acronym SOHCAHTOA. You're going to box in two sides. The first side you box in is the side that we're looking for. So which side, you guys, do they want? Do they want A, H, or O? They want O. They said they put an X here. That's what I'm going to box in. You always box in the side we need to solve for, which is O in this case. Then I get to choose, am I going to box in A or H? What you do is you have to box in the one where they give you a number. right? So Kieran, which side between A or H would I box in? I'd box in H. Yep. So again, you always box in two sides. It's going to be the side that you're looking for, and then they will give you a side. That gets boxed in. Then you're going to say, okay, which trig ratio do I use that has an O and an H? So scan your trig ratios. Jimmy, which trig ratio would it be? Sine. So this is the trig ratio that we're going to use. And here's how you're going to write this. The sine of a given angle is equal to O over H. I know what my given angle is. Hermes, what was my given angle? 52 degrees. So the sine of 52 degrees is equal to O over H. So then what I say is next I write this. The sine of 52 degrees is equal to, I have to take out the O and the H, and I have to plug in what do they want O and what do they want H to be. So O is what they're looking for. That gets the X. So O is X over H is 14.2. I need to solve for X, isolate X, and then I figured out the length of this side. Right now, X is being divided by 14.2. How do I get X by itself? I do what? What's the opposite of dividing by 14.2? Multiplying by 14.2. So multiply this guy by 14.2, multiply this guy by 14.2. Then I've got X by itself, and let's type this in together. X is equal to 14.2 times the sine of 52 degrees. So make sure you're in degree mode. Let's actually check on our calculators. Type in the sine of 90 first of all. So the sine of 90 degrees, what number should come out? 1. Okay, so now I'm going to type in 14.2 times the sine of 52. Here's how you could do it on your calculators. 14.2, you could hit times, or you could just put sine right next to it. But 14.2 times the sine of 52 degrees. And that gives me 11.189. And then I look in the question and they want it to the nearest tenth. That would be 11 point what? 11.2. So then I would say X is equal to 11.2. I look for my units. It was in centimeters. And I just figured out the length of this side here. Just going to erase this. And this guy is 11.2. The only check I'm going to do at this stage is I'm going to say this number has to be smaller than what? What do I know this guy has to be smaller than? Than the 14.2, right? It has to be, this is my hypotenuse, so that's the longest side. So if you got, let's say, 15.3 here, you did something wrong, right? But 11.2, it's smaller than 14.2. Okay, let's do this question. What's often going to happen is no triangles will be given. You have to draw your picture. So it says a ladder is 4.5 meters long. It reaches the top of a wall. So picture a wall, you guys. So this would be the wall. This would be the ground. And then I have a ladder that reaches the top of the wall. So you have to be able to like draw your picture. Okay, now let's see if you could label things. A ladder is 4.5 meters long. Does that get this vertical height here, or is that going to be 4.5 the hypotenuse? What do you guys think? That's the hypotenuse. This is the ladder here. This is my wall. This is the ladder. So a ladder is 4.5 meters long. That goes here. My 90-degree angle goes there. The 4.5 meter ladder reaches the top of the wall. The angle between the ladder and the ground. So here's how I figure out this. I'm going to trace it. Here's the ladder. Here's the ground. This angle here is 65 degrees. Make a rough sketch, which we did, and determine the distance between the bottom of the ladder and the bottom of the wall. Do you know where you're putting your X? It either goes here or it goes here. Ella, what do you think? Bottom of the ladder to the bottom of the wall. Do we want it down here or up here? Down. That's where the X goes. Okay, that would be X. And then now what we have to do, what does it say? Determine that distance. So we've got our angle, give it a set of eyeballs, label everything. Yes, Piper. How do I know this side's not X? So what it said is it said, determine the distance between the bottom of the ladder. So this would be the bottom of the ladder, and this would be the bottom of the wall. That's the distance. How they would have worded it, Piper, is they would have said, if they wanted this guy, determine the distance from the top of the ladder to the bottom, like something like that. Okay, so let's give our angle a set of eyeballs. He stares at the opposite side. 90 degrees stares at the hypotenuse, and by default, X is the adjacent. Write your acronym, SOHCAHTOA. Whenever we are finding a missing side, you box in two sides. Always the side that you're looking for. That is the first thing I'm going to box in. I'm looking for X. That's what I box in. And then Cohen, between 4.5 and this, what do you want me to box in from here? Yes. Yeah, so the second side, it always has to be a side with a number. Okay, then I've got to decide which trig ratio am I going to use. I have to use either sine, cosine, or tangent, and I have to use the one that I've just boxed in. So I boxed in an A, and I boxed in an H. Holly, which trig ratio has A and H? Cosine, right here. So how you write it, the cosine of a given angle is equal to A over H. The given angle that they gave me, Antonio, is what? 65 degrees. So that goes in there. Now what I could do is I could rewrite this, and I need to take out that A and H, and I need to put in what A is, what H is. So I scan here. A is X. So X goes there. H is 4.5, goes there. I need to isolate X. What do you want me to do, Lucas? S from here. Multiply both sides by 4.5. X is equal to 4.5 times the cos of 65. I'm just going to scan up here. It says to the nearest tenth. So 4.5 times the cos of 65. To the nearest tenth would be 1.9. So X is equal to 1.9. What units do you guys want me to write? Meters. So the distance from the bottom of the ladder to the bottom of the wall is 1.9 meters. Okay, now we're going to do, I forget who asked this, Piper asked this one. Now we're going to do determine the height of the wall. So let's draw this exact same triangle, and we're going to put our X over here, because now they want the height of the wall. So let's draw our little triangle. 90 degrees goes there. My ladder was 4.5. The angle was 65 degrees. They want the height of the wall, so that's where I put my X. From here, label your triangle. O, H, and A. Holly, what two sides do you want me to box in? So she said box in that side. Do you want me to box in H or A? H. You have to box in the second side has to have a number. So it's always what you're looking for, and then I need a number because I can't have two unknowns, right? Yes. Okay, so Alexa said, why can I use the number, Alexa, that I originally had? Here's the reason. Let's say you made a mistake, right? Let's say we made a mistake with this guy. I wouldn't want you to put 1.9 here and box that in. You could, and we did it correctly, and it would work. But always go off what you know for sure, right? So we could have screwed this up, and then we'd screw this one up. So that's why I'm going to choose H. Okay, now which trig ratio has H and O? Juan, what do you think? Which trig ratio has the H and the O? Between, yep, my sine, so this guy right here. So always set it up. The sine of your given angle is equal to O over H. The given angle was 65 degrees. And then I'm going to rewrite this. I take out the O and the H, and I put what's actually on my triangle. So sine of 65 degrees is equal to O is X over 4.5. We got to get rid of that 4.5 by multiplying both sides by 4.5. 4.5 times the sine of 65. Oh, so you guys watch. This time I'm not even typing in the multiply. I could type it exactly like this, and I will get 4.0, but they wanted it rounded to the nearest tenth, so I got to round this up to 4.1. So X is equal to 4.1, and I believe it was meters. Now what we're going to do is this last one, and we're going to find the height of the wall using Pythagorean's theorem. So what I want you to do, let's draw our triangle once again. They said that the ladder was 4.5. They want the height of the wall. And what we have to assume is we have to say, like, what was this side that we calculated, right? So this side was 1.9. Okay, so this formula would be, let's say that was A, that was B, this is C. So B squared is equal to, it's always the hypotenuse minus the other side. B squared is equal to 4.5 squared minus 1.9 squared. $16.64 is B, or sorry, is B squared. B is going to be equal to, let me erase that square, a square root of 16.64. Which is 4.1, the exact same answer. Okay, what I'm going to do is we're going to circle our homework. I'm going to set up a couple questions in the homework with you. Then I will upload this video for the students at home to do. And while you're doing your homework, then they could start the video and get set up on this. Okay, you guys open up to your Alexa. Open up to your homework, circle B, D, E, F, G for number 1. So B, D, E, F, G. Number 2, circle, and I'm going to set that up with you. Number 3, circle. 4, A and B. So let's just see why I have number 1B circled. So 1B. Okay, oh, I guess this is why I've got this one circled. According to your given angle, give that guy a set of eyeballs. This would be your opposite side. This would be your hypotenuse. This would be your adjacent. You have to box in 2 sides. You always box in what they're looking for. In this case, they're looking for that side. And you always box in a side that they give you, which in this case would be that guy there. Okay, let's write our SOHCAHTOA. And then say which trig ratio has the A and the O. Anthony, which one do you want me to use that has A and O? tan is correct. So the tan of my given angle, which I'm going to put in as 53 degrees. You guys, can you everybody just look up here? You do not have to write, like when you get good at this, tan of 53 is O over A. You don't have to do that. We have that written already up here. So I'm just going to look and I'm going to say, I know it's O over A, right? So I'm just going to say, what's O and what's A? O is B and A is 9.6. I've got to get rid of that 9.6 because I need to isolate B. So times this by 9.6 times this by 9.6, and you have just solved B. Yes. Say that one more time. Oh, if units are not given, you just write the answer units. I think this one, if I just look in the book, this one just says 12.7. On a test, though, you would say 12.7 units. Yes. Yes. Okay, so Piper just asked, would I ever give this question with B on the bottom? That will be the second part of this lesson. So the second video, I'll do that one in. And it's a quick thing that we do if B's on the bottom. There's a quick thing. Okay, let's set up number 2. So you guys, they gave us our picture, but it's a little bit of a weird picture. I think this is why I wanted to set this one up, because it says the kite string is 65 meters long, and then they got this little dangly thing here, which shouldn't be there. Do you guys know what they want to be 65 meters? So imagine holding a kite. Does a kite go directly above you, or is it the hypotenuse? Yeah, it'd be the hypotenuse. So if I said, okay, where does 65 go? This is where 65 should go. So just imagine, like, visualize a kite, and it's never like right, if the person was, it's never right above. So the person would be holding a kite, the string would be there. So that's 65 degrees. Let's see if you could figure out where the 32 degrees goes. So it says the kite string makes an angle of 32 degrees with the ground. So if you trace, this is the string, this is the ground, that is 32 degrees. Calculate to the nearest meter the vertical height. So this is a vertical height here. That's where they want my x to go. That gets your set of eyeballs, and x becomes my opposite side. 65 is my hypotenuse. By default, that's the adjacent. You'd write your SOHCAHTOA, and you'd figure out which trig ratio has the two sides that you're going to choose to box in. Cohen, do you know what two sides you're going to box in? Yep. Oh, yes. Yep. You'd box in this side, always what you're looking for, what you're given. Okay, so that's the end of the first part of this lesson, and then I will upload the second part as soon as we finish.